All right, welcome back to day 6 of summer school, semester 2 for Algebra 1. Today's topic is looking at exponential functions and graphing exponential functions. So here's some ideas to start with. Okay, exponential functions are defined by an equation of the form y equals a times b to the x. So I'm going to put that over here just so you've got it, okay? If that b value, by the way, b is going to be the growth, the rate of that change for the exponential function. If b is greater than 1, that means that the function is an exponential growth, meaning it's getting bigger as x gets bigger, and that it is an increasing function. If the value of b is between 0 and 1, that means we're going to have an exponential decay function, and that function is decreasing or getting smaller as x gets bigger. Exponential functions have what we call an asymptote. An asymptote is a line which the graph gets close to but never becomes. So the graph's just going to approach that line. It's going to get very, 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 very close to the line, but it's never going to become the line. When you are graphing an exponential function, you're going to want to identify some key pieces of information about that graph. The first thing that you're going to want to decide is this graph going to be an exponential growth or an exponential decay? And to decide that, we're going to look at the number that is the base of the exponent. So in this case, that base is 2, for example, number 1, which means that this is going to be an exponential growth equation. So it's going to get bigger. So it's going to kind of look like that when we're looking at this graph. So a table of values is a great piece of information that you're going to need to know. So we have an x and a y. And it's a good idea to kind of get an idea from -2 to +2 for our x values. So we want to use that information to create this table. So to find our y value, we would take 2 to the -2nd power. And use your calculators to help you with this, absolutely. Make sure you use parentheses. Anytime you're putting a negative number in, make sure it's in parentheses so it doesn't get, so we don't have issues there. So 2 to the -2nd power is 1/4. Your calculator would give you 0.25. When x is -1, 2 to the -1st power is 1/2, which would be 0.5. 2 to the 0th power, anything to the 0th power is 1. 2 to the 1st power is 2. 2 to the 2nd power is 4. So we can plot those points on our graph to get us a pretty good sketch of what we're looking at. So when x is -2, y is 1/4. So I'm just going to put it kind of pretty close there to the x-axis. When x is -1, y is at 1/2. When x is at 0, y is at 1. When x is at 1, y is at 2. And when x is at 2, y is at 4. I usually start at the y-intercept and draw a line to the right, and then draw a line to the left. Notice how that graph is hugging the x-axis. That means that x-axis is what we call the asymptote of our line. That's that invisible line that the graph's going to approach but never become. So let's take a look at the domain. Remember, the domain is all of the x values of our graph. If we look to the left, our x values go on forever. If we look to the right, our x values go on forever. When that's the case, the domain is all real numbers. To talk about the range, as we look up, as x goes to the right, our y values are going straight up to the ceiling. As x goes to the left, we don't go below the x-axis. That's that asymptote. So for this, our y values have to be greater than 0 because we're never going to equal 0. The y-intercept happens when our x-coordinate is 0. So when x is 0, y is 1. And our asymptote in this case is that invisible line, which is the line y equals 0. All right, let's try another example. This is example number 2. First thing we want to decide is if this is exponential growth or exponential decay. In this equation, we have 1/4 as our base. 1/4 is between 0 and 1, so this means we have exponential decay. And now our function is going to look like this. Now it's going to be a decreasing function instead of an increasing function. So when we use our table, we can plug in some values. Again, let's go from -2 to +2. That's always a good starting place for functions when you're trying to get a picture of what they look like. When we take 1/4 to the -2nd power, notice that I'm using parentheses around both the fraction and the exponent. That's super important. You're going to end up with 16. The negative exponent flips the base, so this becomes 4/1, and then 4 squared is 16. When we take 1/4 to the -1st power, the negative flips the base, so this would be 4/1. Anything to the 0 power is 1. 1/4 to the 1st power is 1/4. And 1/4 to the 2nd power is 1/16. So you might get those decimals if you're using your calculator to help you. Okay, so when x is -2, y is 16. That's going to be clear off our graph, way up high. When x is -1, y is at 4. When x is at 0, y is at 1. When x is at 1, y is 1/4. And when x is at 2, y is 1/16. That gets really close to the graph there, so you just kind of have to draw some points right on the x-axis. From the y-intercept to the left, we're going to shoot clear up to the sky very, 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 very quickly. And then from the y-intercept to the right, this is going to approach that x-axis, which is our asymptote again in this problem. Okay, looking at our domain, we're going to go forever to the left, forever to the right, so we get all real numbers. For our range, as we look to the right, we're going to go until we get to 0. But as we look to the left, we're going to go up to infinity. So again, this is y is greater than 0. Our y-intercept still happens at the point 0, 1, and our asymptote is still y equals 0. And really, if you took the notes today, this page is already ready to submit for your independent practice. Okay, let's do one more as an example, just so you can kind of see what's going on. And I'm going to do number 6 as our example, just because there's a lot going on. We're adding some different steps to it. It's not just the exponential function, but now we're moving it around and playing with it a little bit. So we still want to look at the base to decide if this is going to be exponential growth or decay. And since that base is 1/2, this is going to be a decay. So it's going to look like this. It's going to come down as you go to the right. To create our table of values, you are welcome to use a calculator or Desmos to do this. When we still probably want to go from -2 to positive 2. It just really gives you a great place to start. All right, so if we take 5 times 1/2 to the negative second power, I'll go ahead and show you how you can use Desmos to help you get this table of values. So I'm going to open up my Desmos app. You can use Desmos online, or you can download the app. You just go to desmos.com, and we're going to type in our equation right here in the spot where we want to graph. So we have y equals 5 times 1/2, so use the division sign to get the 1/2. Then if you use the cursor, you can kind of come outside of that parenthesis, and you're going to use the A to the B function button, and that's where you're going to put X. Then use that cursor to come down to the main level, then -3. If you don't use that cursor, it'll put the -3 as part of the exponent, which is going to give you a different answer. Now, a couple of different ways you can get this. Probably the easiest way to get to the table is to click on the settings, so that gear icon. If you click on the gear icon, then that first icon there is the table. And that table is going to give you all the information you need for this. So that works really great when we try and put that information into our picture. So if we have -2, we're at 17. -1 is at 7. 0 is 2. So -1 is 7. 0 is 2. 1 is -0.5. 2 is -1.75. So -0.5, -1.75. All right, so when we come over to graph, -2 is going to be clear up here at 17. It's going to be way off the grid. -1 is at 7. 2, 3, 4, 5, 6, 7. 0 is at 2. 1 is at -0.5. And 2 is at -1.75. Here's kind of a hint when we're trying to find that asymptote. This -3 sitting out here, that's going to be our asymptote. So our asymptote for this graph is -3. So y equals -3 is our asymptote. Connect your lines. Notice that this one kind of spreads out a little bit more as you're drawing it, just because of that stretch factor of 5. That's what that 5 does out in front, is it kind of elongates it and makes it taller. So for our domain, we're going to go all the way to the left, all the way to the right, so we have all real numbers. My range, we go all the way up, but we stop when y is -3. So we want y is greater than -3. My y-intercept happens when x is 0, so y is 2. So you've got 3 problems for independent practice today. I would definitely take advantage of that Desmos tool to get there. So again, that is desmos.com. And then you can just go into that graphing calculator. That's an excellent place for you to find those tables of values if they get to be difficult to do by hand. All right, good luck, guys. Thanks for your hard work. We will talk to you on another day.